See, when I'm going to start this particular topic, quantum physics, in which we basically wanted to understand one particular part, like what exactly photoelectric effect is. So main discussion is going to be photoelectric effect. But before I actually start you that part, I wanted to understand something. First thing, when it comes to modern physics or when it comes to particle physics, we need to know that how exactly the energy is calculated over here.
Energy is directly proportional to frequency.
Wonderful. So your energy is directly proportional to frequency, and you say that if I remove the proportionally sign, I have to introduce a constant, and this is a Planck constant.
Yeah.
So it's a simple relation which you can write between frequency and energy. If anybody wanted to convert this, like suppose if you wanted to write in terms of wavelength, frequency can be written as c over lambda, and you can write in this way. But even the wavelength is something which can be written as hc over e. These are different forms, because we already know that c is nothing, it is a product of lambda into frequency. So that actually helps you to transform this particular value in the other forms. And where c is something, remember it is going to be 3 into 10 raised to 8 meter per second. When I'm specifically using c, means I'm talking about speed of light. Got it?
And for h, what will the value be?
The h value is 6.63 into 10 raised to minus 34. It will be given, so don't worry. Okay, so even if you don't remember, it's perfectly fine. Now, part of the experiment, when I say photoelectric effect, first of all, what do you mean by that? Photoelectric effect is something where you need to understand that it is an emission of electron, but that emission is something which is not going to be happen with any kind of a radiation. Okay, so when we define this particular definition or a term, you say the phenomena of emission of electron. This is very important to understand. Emission of electron from the surface of a metal when
light radiation of suitable frequency.
Yes, from the surface of metal when a light of suitable frequency falls on it. Okay, a simple definition. Falls on the surface of metal. Okay, now try to understand what is going to be happen, because this whole experiment is something which I'm going to explain you on the basis of law of conservation of energy. But first, see what is going to be happening. Okay, so we have one particular tube where you can see there is an opening from where the radiation can come in, and in this tube there are two particular metal plates which are present on the either side, like this. Okay, now the diagram will make sense, but for that let me just make it complete. Now look here. Some energy is going to be fall, so I am drawing a light which is coming from this opening, and this light is going to be fall on the surface of a metal. Let's keep our metallic surface still here. This energy the examiner will give you, or this radiation possesses some kind of a frequency which is written as, let's say, f. If you wanted to calculate like this frequency, that means how much energy is falling on the surface of metal, you can say it is hf. Correct?
Yes.
So by just knowing the frequency of radiation by which they are falling on the surface, we simply calculate the energy. It can be written as in terms of hf. Second thing, this material on which they are going to be fall, it always require a certain amount of energy which a metal has to, which an electron has to pay to the metal as a tax, and that is the minimum amount of energy which it will take. Sometimes that particular energy can be written in terms of F naught. That is a suitable frequency which is required so that the electron will come out from the surface of a metal. Okay.
Okay.
If you wanted to write then how this energy can be written, definitely it can be written as H F naught. Are you getting my point?
Yeah.
Okay.
The F naught is the minimum frequency.
Yes, F naught is your minimum frequency or threshold frequency. Now try to understand the same experiment from this diagram, and I hope this will make more sense. See, after a certain points your electrons are present.
Yeah.
Okay, so I'm just drawing this particular electron which are present at a certain depth inside a metal. One thing is very clear over here, that this energy when it falls, the red one, which you already know that it can be calculated by HF. Yeah. The second thing you already know, there is a certain amount of energy which electron has to pay as a toll tax, SALIC, or you can say it is a minimum amount of energy everybody has to pay if they wanted to leave this particular metal, and that is given on this particular well. Okay, so for that there is a special symbol which we prefer to write, which can be this phi.
Okay.
Means it's like, you know, me and you going to the concert, the concert price is 100 AD. Everybody has to pay that 100 AD, then only you can get inside the concert. Correct?
So you need to pay that minimum.
Yes, you have to pay that minimum, then only you will be inside the concert. Inside the concert, how much money you will left with, that depends on how much you have spent before the concert. Like money to pay, buy ticket or traveling, transport, if you eat something before the concert. So whatever the energy which will remain inside the concert, that depends on like how much you have spent. Definitely anybody who is living just next to the place where the concert is happening, he might be having all the money, because if everybody is getting equal amount of money, let's say 100 AD, okay, then what will happen? He is just paying the concert price 20 AD or $20, and he is left with $80 inside the concert. Got it?
Yeah.
So point here is everybody is getting 100, but the one which is going to be maximum amount of money inside the concert is the one which is leaving from the surface, because he is just paying the concert ticket price. But
Okay.
if anybody tried to come from inside the surface, let's say this one wanted to come from here, there is some amount of energy which it has spent to come on the surface, then the concert price, and then it will come out. Means no matter what, if here it has already consumed $20, then you can say that the remaining amount will be left will be what? 20 he has spent to come on the surface, 20 is the concert price, he is left with the $60 or 60 80. Are you getting my point?
Yeah.
But we can say one thing, definitely the maximum amount of money will be possessed by someone who is leaving from the surface. Got it?
Yeah.
So that is something which is very easy to understand by this example. But now look at this with respect to the electron. Everybody is getting the same amount of energy. The one which is leaving from the surface will always have the maximum speed by which it is coming out. The other who are coming from different depth, they might be having a different speed, but the maximum speed who will possess? The one which is leaving from the surface.
Okay.
So you have made a simple formula like amount of energy given is E. W is the amount of energy you are spending to come on the surface. Phi is the minimum energy which you have to pay, and after that whatever remains, the amount of money which you possess, here it will be the amount of energy which you have and by which you will leave the metal. So by using this particular logic, I can simply say that my value of E will look like W plus phi, and where kinetic energy I am writing as Ke. But remember one thing, we usually talk about what? Because if you read this equation in a book, we usually talk about what about electrons leaving from the surface.
W will be 0, right?
Absolutely. And that is the reason you can say that for them W is 0. That means this energy formula which I'm writing, it will be written only in terms of phi and Ke.
Okay.
So this is my Einstein equation by which I'm going to solve the various questions. Correct? And those questions, if you have to solve, what do you have to remember? There are various cases which you have to remember. Like this, energy, or if you wanted to find the kinetic energy, what you can say? Kinetic energy of the electron can be written as E minus phi. And the value of E is nothing, it is the HF, the amount of frequency which is falling on the surface, minus HF naught, the threshold frequency one. So kinetic energy can be simply written as HF, or you can take H common, F minus F naught. Got it?
Yeah.
So this way you will be able to comment on kinetic energy of the electron. Or if you wanted to find what exactly the speed is, then definitely you can write half mv square and this value is there. Okay, now try to understand one more thing I'm giving you. Half mv square hf minus, let's say, phi naught. There is something called as stopping potential. Okay, so this kinetic energy I'm writing it as it is. Now look here. Now with the help of this commutator, what you can do, you can make this plate a negative, and the electrons which are coming out from the surface, these electrons which are coming out with a certain speed, and we know that one will be V max and then they will have different speed. If this is negative potential over here, at a certain point when you keep on increasing the voltage and you increase the voltage to a certain value of V, where this kinetic energy or these electrons are not being able to reach the surface of metal, they come out from the metallic plate with some speed, but finally their speed becomes zero. Why? Because they have been repelled by the negative plate on the other side.
Okay.
And that particular voltage at which none of the electron reaches the other side, and the ammeter will give you simply the value of a zero current. That time what you can say? That you are able to match up the kinetic energy of the electron by simply increasing the voltage on the other side of the plate. And this voltage is known to be a Vs, which you call it as stopping potential.
Okay.
So what do you mean by stopping potential? The voltage at which none of the electron able to reach the other side of the plate, and the value of current shown by the ammeter will be zero. So that means whatever the kinetic energy of this electron is, Ke, you have matched with this particular energy. Do you know that how the voltage can also be written in terms of energy?
QV.
Wonderful. So you can say that work done is equal to QV is the formula. That means you can simply say that here the kinetic energy which you have written, it can be definitely written as QV S HF minus phi naught, and we are talking about what type of charge? An electron. So you can make this value of Q as E. So this is one more way to write this equation.
Okay.
And if specifically they wanted to give the velocity by using the stopping potential, remember this. Kinetic energy is half mv square. You have calculated the work done, or the stopping potential can be written as EV in terms of energy. If you equate these two values also, don't get confused between the two V's. One is for speed and the other is for voltage.
Okay.
You can even find the velocity by 2E Vs divided by m, and then take a square root of this value.
Okay.
And this is the way you will be able to calculate the speed of electron by which they are coming out of the surface of the metal. And this speed is what? Remember this. This whole expression is given when you have taken the work done initially 0. Means you are talking about which kinetic energy? Maximum, 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 maximum. So this speed is also which you have calculated, it is what? Maximum. Got it?
Yeah.